unfortunate accident with some video that I recorded a few days ago. So I actually lost a good bit of footage for some of the steps that have led up to what I have done here so far. But I actually decided I didn't really like the way I went about that anyway. So I sort of changed the design of this fixture to make a fixture, and did some different things anyway. So the first thing I really want to address is the jeweler saw. I had some. This is my saw with the broken blade, and I still have a pack of other blades, and I think the blades weren't really the problem. There's a couple things I learned here. The frame is a little cheap, sort of. I think I might have paid $8 for it, brand new, on Amazon or something. But I think my technique was a little off, and this was what I was sawing, and I think it's a little thick, on the thicker side for what you should really be doing with those saws. So it was more of what I was doing wrong than the saw's fault. So I can forgive the saw. Maybe try something else. So what this ends up being then is a blank that will go on the end of this shaft, and the purpose then of this fixture is to cut divisions in this blank for wheel count spacing on gears for clocks. And then this shaft will be indexed on this fixture to set up on a milling or lathe machine to cut the gear teeth. So this is sort of my test piece. I decided to go with, there's the counts stamped on the back here with my really bad stamping. I decided to go with the first one, which is 750 bolt circle diameter with 36 teeth. So what I ended up doing is accurately drilling a 1/16 inch hole on a 750 diameter, and then that will line up with these slots. So I originally had a dowel pin in here, and then I made a bushing to fit this piece on, and it was not very rigid at all. You can see sort of how not rigid it is. It's not fastened in any way. So that's the video I lost. I scrapped that idea. And so now what I'll show here going forward is the next solution, which is basically like a threaded mandrel. So I did a threaded mandrel that fits in here real nice. Then your blank goes on, and the blank also fits on nice. And there should be a little bit of space up here. And then I made a washer and the screw, so that'll just go together. Everything finger tight is fine. I really don't have to apply a wrench with 5,000 foot-pounds of torque. And then this pin will go in here, and what ends up happening is the pin will then index to those holes. So you'll index to the hole, mill a little cutout here, index it to the next spot, mill a cutout, and it's very light duty work, so there's no need to overly clamp the part. I'll just hold this in a small vise or clamp it to the table, and I think it's going to work out really good. And then once I get one of these done, I'll move on to the further steps on the actual fixture itself, and most of the rest of the work is all nuts and bolts. So but so far I'm happy with this new method of putting the spacings in here. And I also made a mandrel in the meantime to actually turn the wheel blanks after they are half-assedly sawn out of brass sheet. So we'll just look at how I did the little mini mandrel, and maybe a few more things, and then from here on in we'll just do the rest of the project, and it should be finished up here in probably the next week or two. I'm gonna make all of the screws myself, and there's a couple other little components actually. I'm underestimating the amount of work that's left in that fixture. There's quite a bit yet. So far so good. What I have to do now that I've flipped this piece around is ensure that it's running concentric, because when it's in the fixture, it has to be that way for alignment. So what I have is my indicator rigged up here on this diameter, and it's very hard to see, but it is. You'll have to take my word for it that it barely moves. So if I were to spin it, I suppose you could see it there. There's very little movement, probably about 1/1000th of an inch. So I'm going to call that okay. I think that's good enough alignment for what I'm doing here.